Well, hello, fourth grade math teachers. Welcome back to another Prep Talk video. In this video, we're going to talk about division using partial quotients and the standard algorithm. So we're going to talk about some of the star-released questions, some of the strategies that we'll use to teach this concept. And so I hope you're ready to dive in and get going on this beautiful topic of fourth grade math. Here we go. So as we look at the learning objectives that we'll cover in this video, they're pretty straightforward. We're going to represent the quotient of up to a 4-digit by a 1-digit number using partial quotients, and then the standard algorithm of division. And as we take a look at the TEKS that these learning objectives will support, what we notice is that 4.4H is a readiness standard. It has been tested 9 times in the last 5 years. And so this will be a huge TEK that we want to focus on. Now, I have multiplication scratched out here, but we're actually going to look at a question in this video that involves students having to multiply and then divide in order to solve. So as we dive into the strategy of using partial quotients, I want to recommend to you the Math and Practice book, pages 123 through 127. This script that you can use with students to teach them the concepts of partial quotients in order to divide could not be better. And so really dive into it, read through it, look at the questions that are scripted there for you, and then try to follow that as you're teaching this in your class. And I'm going to model this strategy of partial quotients on this star-released question and point out a couple of things that I want you to be aware of in this particular item. There are 1,150 baseball cards that will be sorted into bags. Each bag holds 5 baseball cards. How many bags are needed for all the baseball cards? Now, the first order of business here is students have to know that they are doing division in this problem in order to get the correct answer. Because if they multiply 1,150 by 5, they end up with letter D as their answer. If they subtract 1,150 minus 5, they end up with C as their answer. And so in some ways, you can use that as a way of understanding how to eliminate some obviously wrong answers. We know that because this is a division problem, because we have thought through what strategy we're going to use here, that there's no way the answer could be C or D in this particular case. Now, we are wanting to figure out what 1,150 divided by 5 really is. And so we're going to set this up as a division, putting our divisor on the outside and our product or our dividend on the inside. And what we're going to do is start thinking about what number of bags we could use in order to get all 1,150 into each bag. And so we might start off by saying, oh, I don't know, maybe we could get 10 in there. And so if we took 5 and put them into 10 bags, that would put 50 of those baseball cards into a bag, which would leave then 1,100 left over. Well, we've still got a lot of work to do. So maybe we realize, okay, 10 was maybe a conservative number. That wasn't quite aggressive enough. So maybe we can get a little more aggressive and say, what if we put them into 100 bags? Well, in that case, 5 times 100 would be 500, and that would leave still 600 baseball cards left for us to put into a bag. What we could see then is that we could go for 100 more, and so if we did 5 times 100 again, then that is going to be 500 more, which is going to get us down to 100 baseball cards left. And then from there, students may be able to say, okay, well, earlier we did 5 times 10, which was 50. So if we do 5 times 20, that will get us 100. And so here we will do 5 times 20, which will give us 100, which will get all of our baseball cards into a bag. And so in order to find our quotient, what we will do is we will add together the bags that we did here. And so 10 plus 100 plus 100 plus 20 will be 230 bags. And that will go up here as well to indicate our answer. Now, some students are going to start off conservative and do 10 and 10 and 10. And you'll want to show them that there's a more efficient way to do this. And that's one way that you can differentiate the learning in this particular lesson, because for students that grasp this quickly, you can encourage them to look for more efficient ways to break up the numbers. That's the goal for all students, but many students might need considerable practice with smaller chunks before they are comfortable moving to larger ones. And so you want to make sure that students are having ample opportunity to go through this multiplication through your number talks. And so you might start off your number talks for this lesson of doing things like 5 times 100 or 5 times 20, so that students are remembering those skills, those multiplication skills that will aid the partial quotient process. Let's look at the same question now through the lens of the standard algorithm. When using the standard algorithm, we want students to draw what is called a top-bottom chart. I'll explain that as we go through the problem. Again, we will set this up as a division, 5 being divided into 1,150. Then, because our divisor is 5, that's going to help me figure out my top-bottom chart. I always start my top-bottom chart with 0 and 0. Then on the top, 1, 2, 3, 4, 5, 6, and I can go out as far as I need to for the particular problem. On the bottom, I'm going to be putting the top numbers times 5 in this case, since 5 is my divisor. 1 times 5 is 5, 2 times 5 is 10, 3 times 5 is 15, so on and so on, so that we get the number that's going to go on the top and the number that's going to go on the bottom whenever we do the standard algorithm. So, jumping into this problem, we start off by looking at the thousands place. And how many times can 5 go into the number that's in the thousands place? Well, 5 cannot go into 1 evenly, and so we're going to put a 0 above that thousands place. Then we will multiply. 0 times 5 will be 0. Subtract, 1 minus 0 is 1, and drop down the next place value, which will give me 11. And so now, how many times can 5 go into 11? Well, looking at my top-bottom chart, the number that I see that is closest but smaller than 11 would be 10. And so that means that 5 can go into 10 2 times. And so I'm going to put a 2 above that place value. And on bottom, I'm going to put a 10. And then continue the process. 11 minus 10 is 1. And then I drop down the next place value. How many times can 5 go into 15? Well, hopefully students know that that can go in a total of 3 times evenly, because 3 times 5 is going to be 15, and when I subtract, I'm going to get 0 and then drop down the next place value. And this is where it becomes very important that we are keeping things lined up in our place values in our quotient, because I see that I have one more spot that's available here. And so if I stop and think, okay, well, 5 doesn't go into 0, so I must be done. Well, I'm not done, because I still have a missing place value here. And if I think I'm done, I'm going to choose A as the correct answer, when in fact it's not A. And so how many times does 5 go into 0? It goes in 0 times for a remainder of 0. And so once again, we see that we get 230 as our quotient. And as always, we could have students multiply this back by our divisor and see if we end up with our original dividend, which in this case we do, and so we know that 230 is the correct answer. If students mistakenly ended up with 23 as their answer, then when they multiplied this back, they would get 115, and they would know that that is not correct. And so we want to make sure that they are checking their answer either by then going back and doing partial quotients or by multiplying to see if they get it correct. Part of TEK 4.4H tells students that they must be able to interpret remainders whenever dividing. And so let's look and see how we might do that in this real-world problem. At Camp Hayward, campers can sail on the lake. There are 354 campers in 4th grade, and a sailboat can hold 4 campers at a time. We want to know how many times the sailboat will have to go out on the lake so that all campers will get a turn. Again, students will need to talk with one another, close their eyes, immerse themselves into the real-world context here, try to determine what is going on, read that problem for comprehension, and then determine that this is a division problem. And so if we set up the division, we're going to be dividing 354 by 4, which means that we want to put 4 on the outside and 354 on the inside. To make our top-bottom chart, we're going to focus on our divisor of 4. And so our top will start at 0, go to 1, 2, 3, 4, 5, 6, 7, 8. We could keep going if we need to. And then on the bottom, we will be multiplying the top numbers by our divisor 4. So 0 times 4 is 0, times 1 is 4, times 2 is 8, times 3 is 12, 16, 20, 24, 28, 32, and we could keep going if we need to. Now we start the division process. How many times can 4 go into 3? Well, 4 cannot go into 3 evenly, so I'm going to put a 0 above that place value and multiply. 0 times 4 will give me 0, then subtract to give me 3, and bring down the next place value, which will be 5. Now I'm dividing again. 35 divided by 4. So how many times will 4 go into 35? And looking at my top-bottom chart, what we see is that we might need to go out one more to 9 so that we get 36. And 35 is going to be located in this range, which means that this will be 8 on the top and 32 on the bottom. Subtracting, we get 3, and then dropping down the next place value will give me a 4. And so again, we want to know how many times will 4 go into 34. 34 is in this range, and so that means, again, it will be 8 times, and 32 will go on the bottom, so that we get 2. Now notice that I am out of spots up here on the top, so that means that this number is going to be my remainder. And so that tells me, in this particular case, that in order to get all of these 4th graders on a sailboat over onto the other side of the lake, the sailboat is going to have to come over not just 88 times, because 88 times is going to leave us still with 2 children left over. And so in this problem, we are going to have to do what we call increasing the quotient to 89 in order to get all of the students safely across the lake. And so not necessarily in this week's worth of content, but definitely next week, we will spend some time interpreting remainders and having students determine, do I need to increase the quotient or do I need to forget the remainder? And so that will be a discussion point for your students, not as you're getting going, but as you work through division and the standard algorithm and these real-world problems, you'll want them discussing, do we need to increase the quotient so that we can get our remainder of 2 across the lake, or can we forget the remainder and not have to worry about it? So again, that's not necessarily this week, but it will be coming in future content. We'll finish our discussion on the standard algorithm by looking at this star-released question that involves 2 steps. Meredith had 12 packages of erasers to put into bags. Each of those packages had 43 erasers, and she put 6 erasers into each bag. what is the greatest number of bags Meredith could have put these erasers into? Students will need to think through this problem and then realize that this will involve not just multiplication, but also division. And so breaking this problem apart into chunks can be helpful for your students so that they can think through the different things they're going to have to do in order to be able to answer it. What we see first is that Meredith had 12 packages of erasers and that each of those 12 packages had 43 erasers. And so the first thing we're going to want to do is multiply 43 times 12 in order to determine the total number of erasers that we have in these 12 packages. Multiplying this 2-digit by 2-digit is a good review of some content that you've already covered. And so if we multiply 43 times 2, 2 times 3 will be 6, 2 times 4 will be 8, and then I'm done with the 2. Now I'm multiplying 43 times 10, and so that's going to be 430. And when I add those together, I'm going to get 6, 1, and 5. So 516 is the total number of erasers. And then we are taking those 516 erasers and putting them into bags, and 6 erasers are going to be in each bag, which means we are going to be dividing 6 into 516. So for our top bottom chart, again, we're going to have 0, 1, 2, 3, 4, 5, 6. We can take this out as far as we feel like we need to, depending on the problem and what comes up here. And then on the bottom, we're going to be multiplying by 6. And so 0 times 6 will be 0, times 1 will be 6, and then 12, and then 18. This is basically just the multiples of 6, 36, 42, 48, and etc. if we need to keep going. Now, starting off with the division process, 6 goes into 5, a grand total of 0 times. So I'm going to put a 0 up there on top, and that means that 0 is going to also go on bottom based on my top bottom chart. Subtracting will give us 5, and then taking down the next place value will give us 51. If we go out one more on our top bottom chart, 9 times 6 is 54. That helps students to see that 51 falls in this range, and so 6 goes into 51 8 even times. And so 8 is going to go above my 1, and 48 is going to go on the bottom. When I subtract, I get 3, and I bring down the next place value to give me 6. And then we see that 36 divided by 6 is an even 6. And so a 6 is going to go up there. 6 goes into 36 6 times. 6 times 36 is 36. Subtracting gives me 0. And because I am out of places up here, this tells me that my remainder is 0. And so that means that the greatest number of bags Meredith could have put the erasers into, in this case, is 86. That is my quotient that is on the top up here. You could have students check their answer either by multiplying 86 times 6 to see if they get 516, or by using partial quotients as another method of division to check their answer. Thank you so much for watching this video on partial quotients and the standard algorithm for division. If you have any questions, you can feel free to reach out to either myself or to Sherry Height, our fantastic 3rd through 5th grade facilitator, and we would be happy to answer any questions that you have as you teach this content. And finally, before you go, please be sure to fill out the survey so that you can let us know that you watched the video. You'll have the opportunity to ask any questions there as well, and we can also help serve you better in future videos as we bring you more Prep Talk videos in the future. Thanks so much, and good luck to you and your students as you guys work through partial quotients and the standard algorithm.